So to summarize, the three standard results that we derive based on the integration by parts are like this. Integral of root of a square minus x square is x by 2 into root of a square minus x square plus a square by 2 sine inverse of x by a. And for the other two, which is root of x square minus a square and root of x square plus a square, we see that the first terms are very much similar. That is, we have x by 2 in the beginning, which is multiplied by the same square root expression which is present in the question, and then later we have plus or minus sign. Now a simple way to remember these signs are nothing but this particular sign is same as the sign of a square. In the second, a square is negative, so therefore here we have negative sign, and in the last one a square is positive, so we have once again a square as positive. So we have a square by 2, and in the second and third result we have the log of x plus once again the square root of the same expression which is present in the question. So in this way we can remember these three results. Now let's solve one question using one of these standard results. Here we have to evaluate square root of 4x square minus 9. Now first of all, if you recollect, in all the three results that we just saw, the coefficient of x square must be unity. So since here it is 4, we have to first make it as 1, right? So therefore if we take 4 common, here we have x square minus 9 by 4 remaining in the bracket, correct? So taking the square root of 4, which is 2, outside, we are left with square root of x square minus, and 9 by 4 can be written as some constant square, which is nothing but 3 by 2. So this is exactly of the form now integral of root of x square minus a square, where a is nothing but 3 by 2, as we can relate. So that gives us 2, and using the standard formula, the first term is x by 2 into root of x square minus 3 by 2 the whole square, correct? Now next is the sign is same as the sign of a square, and a square is negative, so here we have minus sign. Then in the formula we have a square by 2, so I write 3 by 2 the whole square by 2. Then we have log of mod of x plus root of once again the same expression which is present in the question, so that is x square minus 3 by 2 the whole square plus c. Now of course let us consider the bracket at the end, because that constant can no doubt be adjusted. So maybe we can call it as say c1. So multiplying by 2 throughout the bracket, we have x into root of x square minus 9 by 4 minus 3 by 2 square is nothing but 9 by 4 log of x plus root of x square minus 9 by 4 plus c, right? So if we want, we can simplify that further, not a problem, so that we can write as x into root of 4x square minus 9, and the 4 which is in the denominator will come out of the square root sign, and that will become 2. So it is x by 2 into root of 4x square minus 9 minus 9 by 4 to log of, here it is x plus once again here also we have 4x square minus 9 whole upon 2 plus c. Now it is sufficient to keep this as the final answer, or if we want we can cross multiply this x with 2, and we will take 2 as the common denominator, and taking the log of that and separating the log can be merged with the constant to make it a new constant, but this is also reasonably sufficient answer. So basically that's the way we use the three standard results that we saw based on the integration by parts.